Hey guys, we're doing notes today over arithmetic sequences and partial sums. So when you've got a sequence, it's just a list of numbers basically, and we have some sort of pattern that tells us how we're able to get from one term to the next term. And so if you'll notice this number right, this little letter N right here, that N refers to the term number. So like if you have a sub 1, that just indicates the first term. If you have something like a sub 54, that just means the 54th term. So if you have an arithmetic sequence in particular, then we have what's called a common difference. And so a common difference is just the number that you're adding each time to get the next term. So let's say you start off with like 5, and then 8, 11, 14, 17, etc. So this is an arithmetic sequence because we're adding the number 3 each time to get the next number. So we would say our common difference equals 3. All right, so let's look at example 1. On example 1, it asks us to list the first 4 terms. So we're basically going to have 4 blanks. It tells us we're going to use this formula right here, and it tells me the common difference is 4. So if I want to get the first term, that means I'm plugging in 1 for n. And so if I start off with that, I get 4 times 1 plus 3, which gives me 7. So my first term equals 7. My second term, I'm going to plug in 2 for n, which gives me 11. My third term, I'm going to be plugging in 3 for n, which gives me, I think I've done something. No, that's right, 15. And then if I plug in 4 for n, I get 19. So hopefully you've noticed that if on that list of numbers right there, the difference between each of those numbers is that I'm adding 4 to get the next number each time. All right, let's do some more. Okay, so in looking at that sequence that we just talked about, one thing I want you to notice is that this formula that they had us using, that's linear. Oops. So it's going to be, every one of these formulas that are for arithmetic will give you a linear equation, kind of in the form y equals mx plus b, where m is your slope and b is your y-intercept, or basically when x equals 0. So we're doing the same thing when we're doing arithmetic sequences. That common difference that we just talked about, this 4 right here, that's going to be the slope that we're using. So when you write the formula, you're going to have a sub n, that's to get any term. You're going to do your common difference times the term number, and then you have to add that to your y-intercept technically, which would be your 0th term. Now in my sequence right here, this 7 that we have right here in front, that is our first term. So we need our 0th term, which means that I need to go back 1 to figure out what the 0th term is. So if you go back 1, you're going to go backwards 4, so you're basically subtracting 4 to figure out that this number right here is 3. So that's where they got that 4n plus 3 right there. So this is how we're going to write every formula for an arithmetic sequence. So in this next one, we have 11, 15, 19, 23, and 27. So in this case, our common difference is still 4. We're adding 4 each time. So if I use this formula, I'm going to do a sub n equals, my common difference is 4, so it'll be 4n. I just need to get my 0th term, so I need to go back 4, which if I just do 11 minus 4, I get 7. So it'll be 4n plus 7. And you can check your work. I mean, if I plug in 1 for n and add 7, I'm going to get that first term, which is 11. If I do 4 times 2 plus 7 to get the second term, I would get 8 plus 7, which is 15, and that's our second term. So you can check to make sure it's right. I mean, it's basically any way that you would have learned in algebra how to write a linear equation, even thinking of a table. I mean, your first term is 11, your second term is 15, your third term is 19, your fourth term is 23. So, figure out your slope. The difference in your y's there is 4. Your difference in your x's is 1. So your slope was 4. Go back to your y-intercept. You would get that y-intercept would have to be 7. to continue that same pattern. So in the situation on the next problem, if we look to see what we're adding each time to get to each next term, I'm adding 2. So if I go, if I write my formula, I'm going to do a sub n equals, we'll have 2 times n, and then if I go back to my 0th term, I'm going to be subtracting 2 from a, so it'll be a minus 2. So this would be the formula that gives me that sequence. Okay, on the next page it has the nth term of an arithmetic sequence. This is an actual formula that you need to have memorized, I guess. I mean, you're still thinking about it in terms like this. It's a sub n equals the common difference times n plus a sub 0. And you're always going to get back into that format when you simplify this form. But this is what you can use if you've already got the first term and you've got the common difference. You could then simplify this to look like the slope-intercept form, basically. So in this example 2 here, we have find the formula of the nth term of the arithmetic sequence whose common difference is 3, and your first term is 2. So basically, if we were to write the sequence for this, if my first term is 2, my next term would be 2 plus 3, so it's 5. And then 5 plus 3 is 8, and then 11, etc. So I can use this formula up here, a sub n equals a1 plus n minus 1, and then d. So plug in your first term, and my common difference is 3. So so we've got the formula technically. We want it to look like this though. So we're going to distribute the 3. So we do 3n minus 3, and then combine like terms, and so you'll get a sub n equals 3n minus 1. So this is the formula that would give you this sequence. And if you think about it, if you're doing an equals dn plus a sub 0, our common difference is 3, which is where we're getting that number right there. This negative 1 right here should be my 0th term, which is what I would get right here in this blank if I go back 3. If I subtract 3 from 2, I get negative 1 for my 0th term. Okay, so another thing I want you to notice is, let me erase this, is looking at this formula. an equals a1 plus n minus 1 times d. If you look at this n right here, it matches this right here. So whatever this term, the number of that term is, that should match that n over here on the right-hand side of the equation. Also notice this 1 right here matches this 1 right here. So we could do any combination of terms. Like if I have like a sub 10, I've got the 10th term, and I've got the 3rd term. Then I could do a sub 10 equals a sub 3 plus, in the parentheses though, instead of saying 10 minus 1, instead of saying n minus 1, I can say 10 minus 3 with that common difference of d. So let's look at the next problem. That will help us here. The 4th term of an arithmetic sequence is 20, so a4 equals 20. The 13th term is 65. So if I think about this formula, so I'm going to use my 13th term and my 4th term. And so in my parentheses, I'm going to say 13 minus 4, and then I'm going to use that to find my common difference. So my 13th term is 65. My 4th term is 20. I'm going to do 13 minus 4, which is 9, and I'm going to use that to figure out d. So subtract 20, I get 45 equals 9d. So d equals 5. That's my common difference. And then this question is asking me to write the first 5 terms of the sequence. I need to know what the first term is. So I'm going to do a1 equals, I'm going to use that formula, but use the 4th term to get it. So in the parentheses, I'm going to say 1 minus 4 times that common difference, which we now know is 5. So my 4th term, again, is 20. That's going to be negative 3 times 5. So my first term will end up being 5. And then we're adding 5 each time. So that'll be 5, and then add 5 to that, I get 10, and then 15, and 20, which I already know the 4th term should be 20, and then 25. So that's our first 5 terms using that formula. If I were to write the actual, we call it the explicit formula when we're writing the formula for this. So anytime you have something that looks like this. That's called an explicit formula. So if I were to write the explicit formula for this, it would be a sub n. My common difference is 5, so it'll be 5n. And then I need to go back to my 0th term to figure out what's going to be added to this 5n right here. So I would subtract 5, which would make it 0. So you could say 5n plus 0, or just leave it 5n. So this would be my explicit formula for this. That would give me this sequence. Now that's one way to do it. Another way is just, remembering, think of this as a table. When my x is 4, my y is 20. When my x is 13, my y is 65. My change in y is 45. My change in x is 9. When you do change in y over change in x, I get 45 over 9, which is a slope of 5. And then remember how to find the equation of a line. How we got it in the form y equals mx plus b back from algebra, and you're going to end up getting this equation. All right, let's do another example. All right, here we've got the 8th term is 25, and we've got the 12th term is 41. So I'm going to do my formula. I'm going to write it down so I can memorize it. And so we're going to do the 12th term with the 8th term. So in the parentheses, I'm going to say 12 minus 8 with the common difference of d. So that's going to give me 41 equals 25 plus 4 times d. Well, when I subtract this, 25 from 41, I get 16, and I get d equals 4. So I'm now going to figure out, this one, I think it wants us to write the first 5 terms, but let's go ahead and find the equation as well. So I'm going to figure out what the 0th term is. So I'm going to use that 8th term plus, and then in the parentheses, I'm going to say 0 minus 8, and then my common difference I now figured out was 4. So to get my 0th term, I would put 25 here. Negative 8 times 4 is a negative 32. So when I subtract that, I get a negative 7. So that's my 0th term. So if it asked me to write the first 5 terms, I know my 0th term would be negative 7. If I add 4 to that, I get negative 3. And then my next term, I'd add 4 to that, and I would get 1, and then 5, and then 9, and then 13. So this would be the first 5 terms. I know my 0th term, that's a sub 0, so I could write my formula if I needed to. My common difference was 4, so it'll be 4n and then minus 7. So this would be the explicit formula. It depends on what the question is asking you for. So that's the explicit formula that would give you this sequence. All right, let's go on to recursive formula. Okay, now we're going to talk about recursive formula. Oh, I just completely marked that out, sorry. I was hoping I could make it where it's a little lighter. Okay, so recursive formula, sorry about that. So recursive formula is going to give you the same information that an explicit formula would give you, it's written differently. So what I want you to think about is when we write it like this is how you write a recursive formula. Notice this is one more than this right here. So basically what that's saying is, like a sub n would be the next term that you're trying to get. A sub n minus 1 is the previous term or the current term that you're working on. And then that plus 2 right there, that's my common difference. That's what it wants me to do to each term to get the next term. So if we have this sequence right here, we would define for you, we would tell you a sub 1 equals 1, and then you would know to add 2 to it to get the next term, and then 2 to that number to get the next term, etc. So just notice the way, the difference. When you have it at an explicit formula, it looks more like this. If you have a recursive formula, it looks like this. So down here on example 4, we have some recursive formulas. We define for you what the first term has to be. They want us to write the first 5 terms. So our common difference for this one is 4. That's our common difference. That means we're going to be adding 4 each time. So we start with the first term, which is 15. My next term then will be 4 more than that. So it'll be 19, and then 23, and then 27, and then 31. So we've written our first 5 terms there. Okay, and then what I want you to think about is our first term was 15. To get our second term, we took the first term and we added 4 to it. So that was 15 plus 4, which is how we got that 19. Or to get the third term, we're going to take the second term and we're going to add 4 to it. So we take 19 and add 4 to get that 23, and so on. So on the next one, our first term is 3.5. So we're going to take that 3.5, and this time this is my common difference. So we're subtracting a negative 2.5. So if A1 is 3.5, to get A2, I'm going to take A1 and subtract 2.5 from it. So that'll be 3.5 minus 2.5, which is just 1. So that'll be the next number in my sequence. To get the third term, I'm going to take the second term and subtract 2.5 from it. So that would be 1 minus 2.5, which is a negative 1.5. So my next term would be negative 1.5. And then I'm going to just continue that pattern. So I'm going to subtract 2.5 again. That'll be negative 4. Subtract 2.5 again, and I get negative 6.5. So this is the first 5 terms with that formula. So looking at the one back here again on A, remember if I were to have written the explicit formula, it would have been A sub n equals, my common difference was 4, and then I'm going to write the 0th term, so I'm going to go back 1 from that, and I would get 11. So this would be the formula that would give me these first 5 terms. So this is the explicit formula, and this whole thing here is recursive. So you'll just need to be able to do both and understand what each one is meaning, basically. Okay, next we're going to talk about how to find the sum of a finite arithmetic sequence. Finite just means it ends at some point. So we've been given a sequence. Basically, this is a sequence that normally has commas. You usually write it like this, all the way up to that 19 right there. So what we're doing when we find the sum is we're adding all of those terms together, which is why we have those plus signs separating them. If I count how many terms we have here, we have 10 terms, which means our n is going to be 10. So when I ask you to find the sum, I'm going to be using this formula right here. So we're doing S sub 10, which means I'm wanting to find the sum of the first 10 terms. My n is 10, so I'm going to do 10 divided by 2. And then when you do A1, that's just your first term, which in this case is 1. When I do AN, that's the last term, which is 19. So we're going to do 1 plus 19. So I'm doing 5 times 20, which is the same thing as 100. All right, so that's a formula you need to have memorized. Another option, though, let me erase this. Another option is to use summation notation. And summation notation looks like this. It has that weird looking E, I guess. You have a lower index and a higher index. The lower index will be some letter, can be X, can be N, whatever. But let's say we want to start with the first term, so N would be 1. And then I'm wanting to go all the way to the 10th term, so on top you're going to put 10. And what that means is I'm doing the sum of the first 10 numbers. Well, in here you're going to put the explicit the explicit formula. So I would need to know the explicit formula. In this case, what I'm adding each time is 2, so my explicit formula would be 2n, and then if I go back to the 0th term, it would be minus 1. So in this case, I would do the summation from n equals 1 to 10, and then in my parentheses, I'm going to put 2n minus 1. And what your calculator does is it figures out the first term. It actually does 2 times 1 minus 1 to get 1, and then it does 2 times 2 minus 1 to get 3. And then it's going to add all of these numbers up after it calculates them. And it's going to give you 100. So what buttons you'll need to press on your calculator in order to get this to show up is if you hit alpha, window, and option number 2. That's going to give you the summation, this little symbol right here for you to type in all the information. All right, let's do another one. So now we're going to find the 150th partial sum. That means we want n to be 150. I know my first term is 5. I have no idea what my 150th term is, but I'm going to need to figure it out. So if I look at this, I can see that I'm adding 11 each time to get the next term. So my explicit formula would be 11n. I need to figure out my, let's see if I can, I need to figure out my 0th term. So if I go back, if I go back 1 from that first term, or by subtracting 11, I would get a -6. So this is my explicit formula. So if I want to figure out my 150th term, I'm going to do 11 times 150 minus 6, which gives me 1,644. So that's my last term right here. So now we're going to do our formula. We're going to do S of 150 because we're adding up the first 150 terms. We'll do 150 divided by 2, and then in parentheses we'll have 5 plus 1,644. So that comes out to 123,675. All right, so one more thing real quick. Let me pause this. Okay, one more thing just to make sure you understand what the summation's doing. If I made this say n equals 2, I don't know, maybe that's even. Let's do n equals 5 to 8. That means I'm adding terms 5 through 8. And let's say my explicit formula is just like n plus 2, something like that. So I'm going to figure out the 5th term, so A5, by doing 5 plus 2, which is 7. So what we're doing is we're doing 7 plus, and then figure out your 6th term, which would be 6 plus 2, so that's 8. So adding 8 to that. And then the 7th term would be 7 plus 2, which is 9. You're just adding 1 each time, because that's our common difference. So I'm adding the 5th term through the 8th term together. So that's going to be 34 when you add those numbers together. And if you were to actually type this into your calculator, you should get that 34. You can also do it by hand, obviously. All right, that's it for these notes. Thanks, y'all.